Namaskaram everyone. Welcome to the mathematics webinar of today. Dear students, today we are going to have lesson 2 of matrices. I'm sure you must have learned matrices first lesson thoroughly, but still there was a little gap between the first lesson and now. So madam will recap and revise what was discussed in the first lesson too. Without wasting much of your time, I take this privilege to welcome and invite Mrs. E.Purnima, PGT Mathematics from TSMS Valigonda, Yadadri Bhongir district, to continue her lesson 2 of matrices. Madam, over to you.
Thank you, ma'am. Good morning, children. Good morning, Sridevi madam, Manjari madam, and the whole webinar team. A very happy good morning. Good morning, children. I hope, as ma'am said, you have understood the matrices chapter of the first session very well. Hope you have done the sums also what I have given you. Let us continue the matrices chapter of today's session. That's a part 2 session. So all of you be ready with your book and pens, children. Book and pen. So let us start our session, children. So what before going to start today's session, first of all, let us recollect whatever we have learned in the previous session. Okay, let's once go through them. So what have you learned in the last session, children? The theory of matrices. Who developed that one? The theory of matrices was developed by the famous mathematician Arthur Cayley. Okay, so he is the person who is behind the development of theory of matrices, children. And why the matrices are useful? They are very much useful in expressing the numerical information in the compact form. This how it is in the last session we discussed in detail, children. Still, if you have any more doubts, you can go through the video of previous session once again. Clear? So now here and what else we have seen? What is the meaning of a matrix actually? What is a matrix? It is nothing but a two-dimensional arrangement in the form of horizontal lines and vertical lines. So we say that the horizontal lines are called as rows and vertical lines are called as columns. And how does a matrix, the elements in the matrix are represented? They are represented in the brackets. One is the square brackets or the this is open brackets. Clear? So these two kind of brackets we can use, but in general most of the times we use the square brackets. This can also be used with children. Okay, so next one is what? The elements. How can you write the elements in the matrices, and how does they denote? The matrices are named by A, B, C, so on. So capital letters usually we denote them, and the elements within the matrix are given by numbers, symbols and expressions. Means anything we can have in the matrix as an element. Clear? So there is no restriction or there is no condition that this cannot be there as an element. So we can have anything as an element in the matrix. Clear? So now here what else we have seen? So this is a matrix. Clear? So this is an example of a matrix. And here what do we have? We have some 3 rows we have. What are they? One is the first R1. This is R1 and this is R2, which is row 2, and and this is R3, which is the highlighted elements. Clear? So these are the 3 rows in the matrix we have, and the same thing matrix once again I'm saying showing you to show the columns. So here how many columns we have? 1, 2, 3, 4, 5. So what are they? Let us see once again. This is the column 1, which is denoted by C1. So this is column 1, and next one is column 2, which is C2, and these are the elements in C2, and next one is C3. These are the elements in C3. Next is C4, which is 0, 1, 1 we have, and column 5, these are the elements we have. Clear? So this is about the rows and columns, how we represent in a matrix. Clear? And next what we have seen, order of a matrix, a very important term. Order of a matrix. What is order of a matrix? It is nothing but the number of rows and number of columns present in the matrix. Usually the rows and columns are denoted by, the number of rows is denoted by M and number of columns is denoted by N. Okay, and the order is given by M by N. You should read this into symbol as by. Okay, so it is nothing but M by N. So always the number of rows should be taken first and number of columns should be taken next. And there is other name for order, that is size. We can say dimension, but most of the times we say order only. Clear? So it is given by what? Number of rows by number of columns. Children, because we have got much means gap is there in between the first session and second session. This time explaining the topics what I have learned in the previous session little more clearly. Okay. Next one is a matrix having m rows and n columns is represented as follows. How do you represent that? In this is a general matrix, children. This is A11, A12, so on, A1n. This is the first row with n number of columns. This is the second row with n number of columns. So on, if you continue, this is the mth row. Mth row with n number of columns. Clear? So these are the rows and these are the columns. So in between we are taking jth column, and here we are taking ith row. Clear? So the elements are always represented. The elements, the general element of a matrix is denoted by Aij. Clear, children? This is nothing but Aij. Clear? Just I am highlighting that one, children. Let us once you see here. Just this one, I'm rounding up to make you more clearly. Aij is a general element, children. So which is the I is representing the row number in which it is there, and j is representing the column number in which it is present. Clear, children? So now here let us move on to the next one. What else we have seen? In any matrix, Aij denotes what? The position of an element. Just now I told you in which row and in which column it is present. Clear? So now here in Aij, what does I represents? It is the row index, and j represents the column index. Index is nothing but where it is present, which number it is present. Okay. Now next one is what? The types of matrices we have seen. In that types of matrices, the first one is square matrix. Square matrix means what? A matrix in which the number of rows is equal to number of columns. So that kind of matrix is called as square matrix. Clear? Number of rows and number of columns should be same. So next one is what? Trace of a matrix. The sum of the elements of a diagonal of a square matrix is called as what? Trace of a matrix. That is nothing but what is the trace of a matrix? If you have the diagonal elements, if you find the sum of the diagonal elements, that sum is called as what? Trace of the matrix. And here the condition is that always a diagonal we can have only for the square matrices. Clear, children? So that you cannot find the diagonal in a rectangular matrix, means where the number of rows and number of columns are different. So there we cannot find the diagonal. So only for a square matrix we can have the diagonal, and the sum of the elements in the diagonal is considered to be the trace of a matrix. Clear? And the next one is what? Diagonal matrix. So what is a diagonal matrix? If each non-diagonal element of a square matrix is equal to 0, then the matrix is said to be a diagonal matrix. So what is that? A diagonal, non-diagonal elements. So other than diagonal elements, rest of all the elements should be 0. So which is a diagonal here? This is the highlighted elements. 1, 5, 6. You can see here, no? So these are the diagonal elements. So other than these elements, how many? If it is a 3 by 3 matrix, we can have other 6 elements we have. Yes or not? Other than these 3. So if it is a 2 by 2 matrix, then you can have 2 elements we have. Clear? So like that, whatever the remaining elements other than the diagonal elements, those all must be zeros. Then only we can say that matrix has a diagonal matrix. Clear, children? So these are the things what I have learned in the last session. So let us move on to our today's topic, what you are going to see in today's class. So what are the learning points of today's class? Still you have more number of matrices, more types of matrices. So we can see the remaining types of matrices, children. And what else we see? Equality of matrices. So next one is sum of two matrices. Next is properties of addition of matrices. Next one is scalar multiple of a matrix. So these are the things, these are the points what you are going to discuss in today's session. Clear, children? I hope in the last session we have discussed the square matrix and diagonal matrix, which is clear to you. And let us see the remaining types of matrices in today's class. So what is the next type of matrix we have? One is a scalar matrix. So what is this scalar matrix? So let us see the definition first. If each non-diagonal element of a square matrix is 0 and all diagonal elements are equal to each other, then it is called a scalar matrix. What is scalar matrix, children? We are saying here the non-diagonal element of a square matrix should be 0 and all the diagonal elements should be equal to each other. So what is it? Let us see here in with an example. Suppose here it is a matrix I'm showing here. It is a 2 by 2 matrix, isn't it? It is a 2 by 2 square matrix. Always remember children, whenever we are saying here diagonal, whenever the word diagonal you are seeing in a definition, that shows that it must be a square matrix, because as just now I said, there is a diagonal for only square matrix. Clear? So now here it is a square matrix of order 2. That is 2 by 2 matrix. Now here this is your diagonal. Yes, this is your diagonal. Now here the other than diagonal elements are what? These are the two elements which are non-diagonal elements. Clear? So the non-diagonal elements are zeros, and the diagonal elements are what? They are, see here, these are the diagonal elements. Clear? Other than these two, we have zeros. The remaining elements must be zeros. Then such kind of matrix is called as what? Scalar matrix. And one more condition is what? The diagonal elements must be zero. Whatever they are, whatever the number they are. They can be expressions, they can be alphabets, they can be numbers, anything. But they must be what? They must be what? They must be equal. Clear? They must be equal. Clear? Now here this is a scalar matrix. Now next one is what? Let us see another example here. Here I am taking a 3 by 3 matrix. Here I am taking a 3 by 3 matrix. Now here it is nothing but, here it is nothing but these are the diagonal elements, minus 3, minus 3, minus 3. Can you find this one? Yes, these are the diagonal elements which are equal. Yes, do you observe, are they equal or not? Yes, yes, very good. So it is here they are zeros, and the remaining elements, remaining 6 elements are there other than the diagonal elements. All the remaining elements are zeros. Clear? So this is a scalar matrix of order 3. Because it is a 3 rows and 3 columns it has, we are saying it as a scalar matrix of order 3. Okay. Next one. Now next matrix is very, very important matrix, which is a unit matrix, or there is other name for it, which is an identity matrix. It is an identity matrix. Clear? Now what is it? Let us see children. What is the definition of it? If each non-diagonal element of a square matrix is 0 and each diagonal element is equal to 1, then the matrix is called a unit matrix or identity matrix. So here also we are seeing the almost same definition as scalar matrix, but only the difference is there the diagonal elements can be any number, they must be equal. Okay, but whereas in unit matrix the diagonal elements should be equal, and as well as they must be one only, they must be equal to 1 only. Other than 1 we cannot have any other number for unit matrix. Is it clear children? So let us see how it looks. Unit matrix of order n is denoted by IN. Means I is a symbol for identity matrix. I is a symbol for identity matrix or unit matrix. Whatever you say, it must be represented by I only. Okay. So of order n, because it is a square matrix, already in the last session I told you. So no need of writing 2 by 2 or 3 by 3. Simply we can write, because both are same. Row numbers and column numbers are same. We can simply represent with a single number. Clear? So here unit matrix of order n is denoted by IN. Okay. Now how it is, let us see. Aij is what? Aij is an element in the matrix. It is n by n is a unit matrix. If and only, this symbol is what children? It is called as, it should be read as if and only if. And just I'm writing here children for your understanding. This symbol should be read as if and only if. Okay. This should be read as if and only if. Okay, so it is an unit matrix if Aij is equal to 1, if I is equal to j. Means I is what? Row index, as we know. J is what? J index. Means if row number and column number are same, then that value must be equal to 1. And it is 0 if I is not equal to j. Means the remaining elements where the row and column number are not same, then that in that place it should have zeros. Okay, now here what is it? Let us see once again. So here what I am showing here, I1 is equal to 1. It is a unit matrix of order 1. Means what here? There is a single element is there because it has only one row and one column. So here that should be a unit matrix of order 1. Next one is what? I2. I2 is what? 1, 0, 0, 1 is a unit matrix of order 2. So it is nothing but here if you see here, I is equal to j, it should be equal to 1 we are saying. What is the position of this element children? What is the position of this one? First one, if you observe here, what is the position of this one? A, 1, 1. Is or not? first, this 1 is located in a first row and first column, isn't it? So here I value is 1 and j value is also equal to 1. So whenever I is equal to j, there we should have 1. Okay. And what is the position of this element? A, 1, 2. Means this element 0 is present in first row and second column. So here I is equal to 1 and j is equal to 2. Isn't it? So here I is equal to j or not equal to j? Yes, it is I not equal to j. So whenever I not equal to j, there we should have 0. And what is the location or position of this element? A, 2, 1. Here also if you observe, I is 2 and j is 1. So I is not equal to j. So there we should have 0. And what about the position of this element? A, 2, 2. Yes, here I is equal to 2 and j is equal to 2. Means what? So here when I is equal to j, there we have 1. So like that you should have. Wherever the value of I and j are equal, there you should have 1 and the remaining element should be zeros. So such matrix is called as what? A unit matrix of order. This is a unit matrix of order 2. And next one more example is what? I3. I1 0 0 0 1 0 0 0 1 is a unit matrix of order 3. Here children always remember, because unit matrix it is almost same to scalar matrices or not. But what about the scalar matrix? Here you can have any number other than 1, you can have any number. So if it is exclusively, if it is 1, then it is called as what? A unit matrix or identity matrix. So always remember children, in the sums, whenever you are doing the sums, there you don't find the matrix. Simply means in the sum you may be given I2. I2 means you should write that matrix is an identity matrix with the 2 rows and 2 columns. That is nothing but 1 0 0 1. If you find I3, that you should write it as 1 0 0 0 1 0 0 0 1. Is it clear? So the matrix won't be given to you. Here it is simply written as I2, I3, I4, so on. It will be given. According to that, you have to write the matrix. So always that's why make practice of writing identity matrices of different orders. Clear children? Next one is what? The third kind of one more matrix is null matrix or zero matrix. So the name itself tells that it is a zero matrix. Zero matrix means where all the elements in the matrix are zeros. Here, if each element of a matrix is zero, then the matrix is called a null matrix or zero matrix. Here, what is the definition? Every element in the matrix is zero. Then the such matrix is called as null matrix or zero matrix. Clear children? That means what? Here one important thing you have to remember, you have to understand is here null matrix or zero matrix need not be a square matrix. Okay children? Null matrix or zero matrix need not be a square matrix. It can be rectangular also. Means here the number of rows and number of columns need not be same. Understood? So now here it is denoted by, this is O. This symbol is what? O. So zero matrix is denoted by O m by n. Clear? Or you can read it as 0 also we can read children. So 0 m by n. It is denoted by O m by n of order m by n or 0 m by n. Clear? So here, because here I am showing m by n. M is different and n is different. That means what? Rows and columns may be different. They may be same or they may not be same. So next one here, O2 is equal to or 02 is equal to 0000. Here simply I am showing 2. Means what? Rows and columns are same. This shows that rows and columns are same, equal in number. So all elements are zeros. Clear? Next one more thing I am showing you. Zero matrix of order 2 by 4 is equal to, that means what? The first number denotes row numbers, number of rows. And second number denotes number of columns. So here it is first row and second row. 1, 2, 3, 4. 4 columns are there where every element is 0. So this is a zero matrix. Examples for zero matrix. Here we have the square matrix, square zero matrix, and here we have rectangular zero matrix. Clear children? So you can have anything for a zero matrix. Next one is what? Next important one is what? Row matrix. What is a row matrix? Row matrix is nothing but a matrix with only one row is called a row matrix. A matrix with only one row is called a row matrix. Means it can have any, we are specifying here, we are giving a condition for only row. We can have only one row. But we are not telling about columns. That means a row matrix can have any number of columns, but only it should have only one row. Clear? So what is that? Let us see an example. A is equal to 1, 2, minus 4. I'm taking the elements here. So what is here? How many rows are there? One row is there. How many columns are there? 1, 2, 3. 3 columns are there. So it is a row matrix of order 1 by 3. Clear, children? So like this we can have any number of rows. Some 5 row, 5 columns, 6 columns, 7 columns. We can have any number of columns. But the condition is that it should have only one row. Clear? Then it is called as a row matrix. Next one is what? Column matrix. What is a column matrix, children? It is a matrix with only one column. It's called a column matrix. It is also similar to row matrix. But here the condition is that it should have only one column. And similar to the same thing what I told for row matrix, there is no condition for number of rows. So you can have any number of rows, but only one column it should have. Then it is called as what? Column matrix. Is it clear, children? So let us see how it looks. A is equal to 3, 1, 0, minus 3. Clear? So how many rows it has? 1, 2, 3, 4. 4 rows. Can you observe 4 rows here? Yes? Very good. So here we have 4 rows and only one column is there. So it is called as a column matrix of order 4 by 1. Always number of rows should be given first, children. Okay. So whatever the matrix is, whether it is a row matrix or column matrix, number of rows should be given first only. Okay. So it is of order. It is a column matrix of order 4 by 1. Clear, children? Are you following? Next one is what? Triangular matrices. Here we have triangular matrices. I'm saying means I'm giving a plural word here. So why I'm saying here plural? Here we have triangular matrices. In this we have two types of matrices. We have one is the upper triangular matrix, and other one is a lower triangular matrix. So let us see one by one. So the first one is upper triangular. What is upper triangular? A square matrix A is equal to Aij is said to be upper triangular matrix if Aij is equal to 0 for all I greater than j. I represents what? The number of row in which the element is present. And j represents what? The number of column in which the element is present. Is it clear? So if the row number is greater than j, column number, then in such case the element should be 0. That element must be 0. In all other cases, it can have any number. Is it clear? So let us see how it looks like. Example. So this is a matrix I'm giving. Okay. So what is the position of this element, children? A11. Is it clear? It is A11. What is this? A11 means what? I and J are equal. Yes. And what is this? A12. A12 means what? Row number is 1 and column number is 2. First row, second column. Yes. So I is greater than J or less than J? Yes, you are right. That is less than J. I is less than J. But here our condition is what? I should be greater than J. When I greater than J, there you should have 0. And what is this? A13. Here also I is 1 and J is 3. So again I is less than J. And what about this one? Second row, first column. So here it is A21. What is the position of this element? A21. So what is I there? Second row, that is 2. And first column means J is what? 1. So now here it is A21 means I is greater than J, isn't it? So when I is greater than J, here we have how much? What is the value should have here? It should be 0. Do we have 0 here? Yes. And what is this one? A22 means second row, second column. So where I is equal to J. So it can have any other number. And what is this? A23. I is less than J. I is second row and J is third column. J is 3. So that's why I is less than J. And what about here? A31 where I is greater than J. What is this? A32. Third row, second column. Again, I is greater than J. So here in these three cases, we are getting I value greater than J. So here we have zeros. And what about this I? What is this element? A33 means I is 3 and J is 3. So both are equal. So when both are equal also, we can have any number. Only the case where I is greater than J, there only we should have zeros. So here these are the three elements where the row number is greater than the column number. So here we have zeros. So this kind of matrix is called as what? Upper triangular matrix. It is called as upper triangular matrix. Means if you observe here, it is a triangle. It is forming a triangle. 2, 3, 3, 2, 4, 6. If you see, if you join these numbers, it is what? It is a triangle. It is forming a triangle. So let me join here, children. I'm trying to join, children, this one. Yes, what is it forming now? It is forming a triangle. So where it is forming above to this, no? So it is called as a upper triangle. Above to it is forming a triangle. So it is called as an upper triangular matrix. Clear? Similarly, let us see the lower triangular matrix. One more example we see here, children. So here also only it is a 2 by 2 matrix. Only here we have the row number greater than column number. So then also it is called as an upper triangular matrix. Clear? Next one is lower triangular matrix. Same definition, children. Only the difference is the place where the element should be 0 is where I less than j. Clear? So now here example, if you see, these are the elements we have seen here: 2 0 0, 1 2 0, and minus 2 1 6. And what the same explanation what you have seen in the upper triangular matrix. What is the position of this one? First row, second column, means A1 2. Yes, I value is 1 and j value is 2. So I is less than 2, isn't it? So here we have 0. And what is this? A1 3. Again, row number is less than column number. That is I less than j. So here also we have 0. What about this one? Second row, third column. So A2 3. The position of this element is A2 3. So that means I is less than j. So here also we have zeros. And remaining all the elements, if you observe the positions, A11, A21, A22, A31, A32, A33. In all the cases, either I is greater than j or I is equal to j. Yes or not? So that's why here we can have any numbers. Only the place where the I is less than j, there you can have zeros. Okay. Such matrix is called as what, children? Lower triangular matrix. Again, here also if you observe the same thing, if you join these elements to understand it clearly, it is what now? It is forming a triangle. It is forming a triangle below to these 3 zeros. Yes or not? So that's why it is called as what? Lower triangular matrix. It is called as lower triangular matrix. Let us see one more example here. A 2 by 2 matrix. Here we have the A1 2. Its position is A1 2. First row, second column. So here I less than j. So here we have 0. And the remaining all elements are forming a triangle where I is equal to j or I greater than j. Clear? So these are the two examples for lower triangular matrix. Okay, children. So now here let us move on to our next topic. So till now we have seen the types of matrices. Now here we are going to see equality of matrices. What is the meaning of equality? Some both means where we say they are same. When something we say it as same, when you compare any two things, when you means observe that they are same, so then we say that they are equal. Yes or not? So here when you are comparing, when you are talking about comparison, we need at least two. At least two things we need, whatever it is. It may be whatever you compare. Here we are talking about matrices. So here we need two matrices. So that's why here we are taking what? We are taking two matrices. Matrices A and B are said to be equal if A and B are of the same order and the corresponding elements of A and B are the same. So what is it, children? When you say the two matrices are equal, here I am taking two matrices, one is A and other one is B. When can I say that these two matrices are equal? First condition is that they must be of same order. So when you are talking about equality, in everything, in every aspect, they must be same. Okay. The first thing is what we consider the order. So both matrices must be of same order. Okay. So if they are of same order, then what about the elements in that? The elements must be same. The elements must also be same. But what means how the elements should be, how the elements are, means where the or which kind of elements are same. The corresponding elements are same. The corresponding element should be same. So what is it? Let us see in detail. So here it is a general matrix I am taking, children. A is equal to A11, A12, A13. These are the positions of the elements. Clear? And this is another matrix B11, B12, B13, B21, B22, B23. Is it clear? So these are the two matrices we are taking. Clear? Now, what is that? Matrices A and B are equal if Aij is equal to Bij. If Aij is equal to Bij. So Aij means here every element is Aij only. Yes or not? Here Aij and here it is Bij. Means here where Aij A11 is there, here B11 is there. So Ij must be same. So this element and this element must be same. Clear? So where what is the position of this element here? The same element should be there in the same position. So then we say that similar to all elements here. Understood? So then we say that the two matrices are equal. First condition is that they must be of same order. And second condition is that the corresponding elements must be same. So what are the corresponding elements? Let us see an example, children. These are the two matrices just now we have seen. So which are the corresponding elements here? Let me explain. A11 and B11. Is it clear? So these two are, means the position should be same. Where this element is located, in the other matrix also that element should be located in the same place. Okay. So these two are corresponding elements. Similarly, these two, A12 and here B12. These are the two matrices, these are the two elements which are corresponding to each other. And next one is what? A13, B13. These two are also corresponding elements. Only here, children, to make the different, means to show you the difference that this is a different matrix and this is a different matrix A and B. I'm using here, it is these are the elements in the B matrix, B11, B12 I'm showing. Clear? But when it comes for the elements, when you write as the numbers, they must be same. Okay. So understand that. Only the positions I'm showing like that, B11, B2, B12, so on. Now next one is what? A21 and B21. These two must be, means here where it is located, second row, first column. Here also second row, first column element should be same. Next is what? A22, B22. Next one is what? A23, B23. So these are all the corresponding, like that how we see the corresponding elements. They must be same. Okay. So if they are equal, then we say that the two matrices are equal. Clear? So let us see with an example. Let A is equal to 2, 3, 0, minus 1. So let us take another example. Another matrix B is equal to 2, 3, 0, minus 1. Okay. So let us first compare. Let us see first of all what is the order of these two matrices. Yes, they are of 2 by 2. It is a 2 by 2 matrix. It is a 2 by 2 matrix. Clear? So let us compare the elements also. First place, first row, first column. Here also first row, first column. Here are they same? Yes. Are they same or not? Yes, they are equal. Next, let us compare another element. Here first row, second column. Here also first row, second column. I'm trying to compare these two. Are they same? Yes, they are equal. Next one is what? Second row, first column. Let us compare the elements. In the second row, first column, what do we have? Both the matrices we have 0 only. So are they equal now? Yes, they are same. Next, second row, second column. They are also same. So that means what? Here we are comparing the corresponding elements in the two matrices. We have observed that they are same. And one more condition we need to check now. What is that? Their order. They must be of same order. So let us check. A is of which order? As just now we have discussed, 2 by 2 matrix. 2 rows and 2 columns are there. B is also of order 2 by 2. It means are they of same order or not? So they are of same order and as well as the corresponding elements are also same. So now from these two observations, what can you say? That A is equal to B. Understood, children, how to compare any two given matrices? See, it is not that only two matrices can be compared, children. We can compare any number of matrices. Clear? Only the thing is that the two conditions must be verified. What is they must be of same order. See, if either of the condition is not satisfied, then they are not equal. They are said to be not equal. Clear? Means if they are of different order, then the condition is not verified. And if suppose they are of same order, but the elements, the corresponding elements are not same. Clear? So then also we say that the two matrices are not equal. A is not equal to B, we write. Is it clear, children? Next, let us see how to add sum of two matrices. Means what? Sum is nothing but addition. Sum is nothing but addition. So how can you add any two matrices? So here it is given that sum, but the same thing we can say for the difference also, children. Means we can add or we can subtract. So for the both the things, the conditions are same. Clear? For both kind of operations, by adding the two matrices or for subtracting the two matrices, the conditions are same. So what is that? Let us see. Let A and B be matrices of same order. The condition should be what? They must be of same order. Then the sum of A and B denoted by A plus B is defined as the matrix of the same order in which each element is the sum of the corresponding elements of A and B. What is it, children? The first thing is that to add any two matrices, the first condition is that they must be of same order. Then only addition is possible. Remember that, children. Then only addition is possible. When two matrices are of same order, then only the addition is possible. Is it clear? Next. So now let us see that they are of same order. Means addition is possible. If addition is possible, then we try to add them. Then how can you add? After adding, what we get? We get a sum. That sum is denoted by what? That sum is denoted by A plus B. That sum is denoted by A plus B. So this is also a matrix. The resultant is what? The sum is also a matrix. And what is the order of this resultant matrix, or what is the order of this sum matrix? It is also of the order, same order, in which A and B are there. Understood, children? So when you are adding two matrices, the resultant matrix, that is the sum matrix, will also have the same order as how the A and B have. Clear? Whatever they have, the same order this have. Next. So okay, when you're adding two matrices, the resultant matrix order also we came to know. But what to add means which when you are adding two matrices, which are to be added, which are to be added or what are to be added. Let us see here. The elements, the corresponding elements of A and B must be added. Understood, children? The corresponding elements of the two matrices A and B should be added. So let us see how it is. A is equal to Aij. It's a general matrix of order m by n. Okay, and B is equal to Bij of order m by n. Clear? One thing you understand, children. When you are adding any two matrices, it is not must that they should be a square matrix. Clear? They can be rectangular matrices also, but only the condition that A and B, the matrices which you are adding, those two must be of same order. If it is of order m by n, then B should also be of order m by n. Is it clear? Only this is the condition you have to check. Next, then A plus B is equal to, there is some other matrix. Means after adding the corresponding elements, we get different elements, yes or not? So that I am taking as Cij, where Cij is equal to Aij plus Bij. Means Aij is an element in the A matrix, Bij is an element in the B matrix. When you are adding these two corresponding elements, the sum what you get, that is taken by as Cij in general, and the order of that matrix is given by m by n. Clear? Understood, children? So let us see with an example to have more clear understanding. A is equal to 2, 4, 0, minus 1. This is the matrix. And B is equal to 3, 5, 2, 1. Is it clear, children? So now here what are the corresponding elements, children? 2 is corresponding element to 3. 4 is the corresponding element to 5. And 0 is the corresponding element to 2. Minus 1 is the corresponding element to 1. Now you understood which are corresponding elements. So always the corresponding element should be added. Now which we are adding now? We are adding the corresponding elements in the two matrices A and B. So that the resultant matrix is denoted by what? A plus B, isn't it? So when you are adding these two matrices, I am writing it as A plus B is equal to the corresponding elements 2 plus 3, 4 plus 5, 0 plus 2, minus 1 plus 1. Is it clear, children? Now what is the sum here we get? A plus B is equal to, what do we get? 2 plus 3 is equal to 5, 4 plus 5 is equal to 9, 0 plus 2 is equal to 2, minus 1 plus 1 is equal to 0. So like this, how we add the matrices. Understood, children? The same thing, children, once again I am telling you, the same thing we can do for difference also. If suppose in place of this A plus B, if I have here A minus B, then what we do? We subtract the corresponding elements. Instead of 2 plus 3, here we write it as 2 minus 3. 4 plus 5 means 4 minus 5. 0 plus 2 means 0 minus 2. Minus 1 plus 1 means minus 1 minus 1. Clear? So like this we write. And here the matrix is given by, the resultant matrix is given by A minus B. Is it clear, children? The rule is same, the condition is same. Only the thing you have to remember is two matrices must be of same order and the corresponding element should be added or corresponding element should be subtracted, whatever you do. Is it clear? Next thing is, let us see some properties we have. When you are adding the matrices, properties of addition of matrices. What are the properties we have? Let us see. Okay. The first one is in the lower classes, you learned about different properties, children. That is the commutative property, associative property, with numbers you have seen. Yes. The same kind of properties we can apply for matrices also. So how does they look? Let us see now. The first one is, first let us represent the matrices. Let A is equal to Aij of order m by n, B is equal to Bij of order m by n, C is equal to Cij of order m by n. If you observe the three matrices, all the three I am taking of same order or of same order, because as already I told you, whenever you are adding the matrices, the order must be same. Is it clear? So how many matrices you may take? Every matrix should be of same order. Is it clear, children? So now what is the first property we are going to see? First property is commutative property. What is the meaning of commutative property? A plus B is equal to B plus A. Means first I am adding A plus B, means the corresponding elements of A plus the corresponding elements of B. After doing that, we get a matrix A plus B. Suppose if I change the position, means order of the matrices, order in the sense not this order, children. B plus A means first I'm taking the B as the first matrix and A as the second matrix. Here what I took, A as the first matrix and B as the second matrix I took. Yes, I got A plus B matrix. Suppose if I take B plus A, means B is the first matrix and A is the second matrix, then also the product does, sorry, the sum does not change. The resultant matrix does not change. Both will be equal. How can I say they are equal? Here A plus B is a matrix, B plus A is also a matrix. Yes or not? So how can I say that they are equal? Yes? Can you guess? How can you say that they are equal? Just now we have discussed about equality of matrices. No. How can you say that the two matrices are equal? They must be of same order and as well as the corresponding elements must be same. So after getting these two matrices, if you verify their order and as well as their corresponding elements, they should be same. Clear? So they will be same. Okay, you have to verify with an example also. You can verify with an example. Next one, second one is what? Associative property. Here associative property is what, children? A plus of B plus C is equal to A plus B of plus C. What is it, children? Here we have, when you are saying about associative property, we need to have three matrices. That is A, B, C. So that's why here I took C matrix also. So A plus of B plus C means what? First we do the sum of the two matrices which are within the bracket. B plus C we do. Clear? Then to that resultant matrix, we add that resultant matrix to the matrix A. A plus of B plus C. Clear? So next, what is the other side? We have A plus B of plus C. Means first we do A plus B, then to that resultant matrix, we add the matrix C. Okay. So then if you compare the resultant matrices of LHS and RHS, both will have the same order and as well as same corresponding elements. So that's why we say that these two are equal. Okay, that means matrix addition holds commutative property and as well as associative property. Understood? Next, third one is additive identity. Additive identity. What is the meaning of additive identity, children? Usually in numbers, uh, here I'll show you just an example here. Okay, usually if I have a number 1, okay, 1 or 2, so on, whatever it is. So how much if I add here, will I get the same number 1? How much should I add here to get the same 1 here? Yes, yes, you are right. There should be 0. So if I add 0 to any number, it may be 1, it may be 2, it may be -1, whatever it is, to get the same number as the sum, we should add 0. Is it clear? Isn't it? So similarly, when you're talking about the matrices, what is our 0 here in the matrices? It is nothing but 0 matrix. So to any matrix, if you add 0 matrix of the same order, when you always remember, whenever you are adding, I need not to tell every time, children, you have to understand that whenever you are saying that adding, that is understood that both are of same orders, both are of same orders. So they can be any ordered matrix. It can be a square matrix, it can be a rectangular matrix, but the 0 matrix should also be of same order as A. Clear? A plus 0 is equal to 0 plus A. Means if you interchange the matrices, 0 is matrix is in the first position, and A is in the second position. Then also we get the same matrix A. Clear? So that's why here we say that this 0 is called as what? Where it is a null matrix, we know that as of the same order m by n. Here 0 is called as what? Additive identity. In the our number system, we say that 0 is called as additive identity. Similarly, here the 0 matrix is called as the additive identity. Is it clear, children? Next one is what? Fourth one, additive inverse. Here, when you are talking about inverse, a plus b is equal to b plus a is equal to 0. Here also I'll explain you with an example with the numbers. Okay. See here, suppose here if I have, 1, okay, plus dash is equal to 0. Here 1 plus how much I should add here to get the sum as 0. Sum should be 0. So what should I add here? 1 plus how much will give you 0? 1 plus minus 1, isn't it? Yes or not? So 1 plus minus 1 is will give you the result as 0. Yes. So this minus 1 is called as what? Additive inverse. This minus 1 is called as additive inverse. Clear? Similarly, if I have here, suppose minus 1 is my number, plus dash is equal to 0. So how much I should add here to get it as 0? 1. Isn't it? So 1 plus of minus 1 is equal to 0. Minus 1 plus 1 is equal to 0. Means if I interchange also, that doesn't make any difference. So that means what here? Minus 1 is called as additive inverse of 1. In this case, 1 is called as additive inverse of minus 1. That means what? They are mutually additive inverses to each other. Isn't it? Similarly, here if you see here, a plus b is equal to b plus a is equal to 0. Here that means what? When you are adding a plus b, that sum you are getting as 0. Then what is this b called? This b is called as what? Additive inverse. As same as I explained in this example. When you are adding any two numbers, if you are getting 0, then this number is called as what? Additive inverse we are saying. Similarly, here also a plus b is equal to 0. That is nothing but 0 matrix. Okay. So if A plus B, if two matrices are added, the resultant is a 0 matrix. Then we say that this B is called as what? Additive inverse of A. Additive inverse of A. Clear? Similarly, if B plus A is equal to 0, then this A is called as additive inverse of B. Understood, children? So here we say that, and here what is that additive inverse? Minus 1 here we are saying. Here also, what is that additive inverse? If A plus B is equal to 0, then what is B value? B is called as additive inverse, and what is its value? It is nothing but minus A. It is nothing but minus A. So the general maths we can do. A plus B is equal to 0 means B is equal to what? This A will be sent other side, becomes minus A. Isn't it? So this B is equal to minus A is called the additive inverse of A, because we know that B is the additive inverse of A. So what is B? Minus A. It is called as additive inverse of A. Means whatever the value of whatever the elements in the matrix A, that elements should be given multiplied or with the minus sign. Each element of A should be multiplied with the minus sign. Then that becomes the additive inverse matrix. Understood, children? So you will understand it more clearly when you are doing the sums based on it. Clear? Scalar multiple of a matrix. What is a scalar multiple of a matrix? Let A be a matrix of order m by n and K be a scalar. Scalar is nothing but a constant, children. There is no specific meaning in that. It is nothing but a constant quantity. So it A be a matrix of order m by n and K be a scalar, then m by n matrix obtained by multiplying each element of A by K. is called a scalar multiple of A and is denoted by Ka. Clear? So what is it? I am taking a matrix of order m by n, and let us take a quantity constant K. So if I'm multiplying this matrix A with that scalar quantity K, then what happens? What we get whenever you multiply something? What is the result we get? We get a product. Yes, the product matrix. How do we get the product matrix? That is nothing but the element, the each element in the product matrix is obtained by multiplying each element of A by that K. Understood? So then it is called as scalar multiple of A. So what is it? Let us see here. If A is equal to Aij of order m by n, then Ka is equal to K into Aij. Means every element of this A matrix is multiplied with K. Then that is nothing but that product matrix is called as the scalar multiple of A. Is it clear, children? So let us see here an example. If A is equal to 2, 0, minus 3, minus 1, okay, and K is equal to 3, then what is the scalar multiple of this A? I'm trying to find out Ka is equal to, in place of K, I'm replacing 3. 3A is equal to, every element of A is taken as multiplied with 3. 3 into 2, 3 into 0, 3 into minus 3, 3 into minus 1, so on. Clear? Now here it is nothing but Ka is equal to 3A, which is 6, 0, minus 9, minus 3. Clear, children? So it is a scalar multiple of A, matrix A. Okay. Now these are the things what you have learned in today's session, children. So here let us once again let us see in brief what have we learned in today's session. So what you have seen, types of matrices. What are the matrices we have seen? We have seen in today's session: row matrix, column matrix, scalar matrix, unit or identity matrix, null matrix or zero matrix. Okay, so these are the matrices we have seen. And next, what else we have seen? Equality of matrices. When two matrices are said to be equal, they must have the same order and their corresponding elements must be same. Clear, children? So then we say that the two matrices are equal. Next one is what? Sum of two matrices. Means when can you add any two matrices? When they are of same order and as well as the corresponding element should be added. The corresponding element should be added. Of the two matrices should be added. Clear? Next, and the resultant matrix is also having the same order as the two given matrices. Clear? Next one is what? Properties of addition of matrices. So we have discussed few properties. One is commutative property and associative property, additive identity, additive inverse. Clear? What is additive identity matrix? Is zero matrix, because whenever you add zero matrix to a matrix, we get back the same matrix. So that's why the zero matrix is called as what, children? Additive identity. And similarly, additive inverse. What is additive inverse? In means whenever you add any means inverse to a given matrix, you should get the zero matrix as a sum. Okay, so that means what? A plus B is equal to 0 means what is the B? B is called as additive inverse, and what is its value? Minus A. Means the matrix A is, every element of matrix A is multiplied with minus sign. Means if the element is plus, then that becomes minus. If the element is minus, that becomes plus, because minus into minus becomes plus. No. Yes. So that is the additive inverse matrix. Next one is what? Scalar multiple of a matrix. What is scalar multiple? When any given matrix is multiplied by a scalar quantity K. Clear? So then the resultant, the product matrix is nothing but your Ka. Means where every element of the matrix is multiplied by that scalar quantity K. Then that the product matrix is called as a scalar multiple of a matrix. Is it clear, children? So these are the things what you have learned in today's session. I hope you enjoyed the session. You understood it clearly. Once you go through the textbook also, children, because there you can find out the examples and sums, and once again you go through the video. Still, if you have any more doubts, you can put it in the chat box in the next session. Clear? We can clear the doubts. Now let me give you some questions to understand, means how much you have understood. To see it, let us see. First question is, if A is equal to 133,154 minus 206, then Find 5A. What is it, children? It is nothing but the scalar multiple of the matrix A. So what is the K value here? The scalar quantity is 5. So how can you find out this 5A? Just now I explained you. Okay. Every element of this matrix should be multiplied with 5. Okay. That will give you the 5A matrix. Next, second question is, if A is equal to 1, 2, 3, 3, 2, 1, then and B is equal to 3, 2, 1, 1, 2, 3, then find the 3B minus 2A. So what you should do, you have given two matrices, children. One is the matrix A and matrix B. You are asked to find out 3B minus 2A. That is nothing but 3B means scalar multiple of B we should find out with a scalar quantity 3, and 2A we should find out. Then subtract these two matrices. Subtraction, just now I said sum of the matrices or subtraction both are same. Clear, children? So here sum of the matrices, difference of the matrices is there here. Means 3B, first you should take the 3B matrix first, then 2A matrix should be taken next. Then the corresponding elements of the two matrices should be multiplied. Okay. Next one is, third question is, find minus 1, 2, 1 minus 2, 3 minus 1 plus 0, 1 minus 1, 0 minus 2, 1. Find the sum of these two matrices. Okay. Fourth sum is A is equal to minus 1, 3, 4, 2. B is given as 2, 1, 3 minus 5. X is given as x1, x2, x3, x4. Okay. Now here I am giving a condition that A plus B is equal to x. So it is given in the question that A plus B is equal to x. Means when you add these two matrices, that is equal to our x matrix. It is given. Okay. Then from there you have to find out the values of x1, x2, x3 and x4. When you know, means what you know about equal matrices, A plus B is a matrix, resultant matrix when you add these two matrices. Yes. Then after that you have to equate that matrix to our x matrix. So what do you know about equal matrices? The corresponding elements are same. So when you compare the corresponding elements, then you will find the values of x1, x2, x3 and x4. Clear, children? So try to do these sums. Hope you have enjoyed the session. Thank you, children. Thank you, ma'am, for giving me this wonderful opportunity. Thank you so much. Good day.
Thank you, Purnima madam. That was a wonderful explanation. Uh, I'm sure, though it is very easy, until and unless the students practice, they won't be able to do the next problems. So I'm sure the students will follow and solve all the questions that you have given in the practice work. Not only that, dear students, go through the textbook and try to solve all the exercise problems and all the example problems, which will help you in learning matrices easily. This is the first time you're learning about matrices. And if you just take a little more time, it will be easy and scoring as well. You can score marks easily in your examination if you are thorough with the basic operations and know how to add and subtract and then multiply matrices. I'm sure you'll do that. Thank you, Purnima madam,
Thank you.
for taking such a wonderful lesson. Thank you.
Thank you.